Welcome to EDU World Space.
In this problem, we're going to talk about projectiles. So consider that we have a projectile that's launched with an initial angle of theta. So this angle here is theta. And we want to describe the projectile's trajectory in the y and x directions. So all we have to do is to notice that the only force that acts on the projectile is in the y direction, and it's pointing downwards, causing the object to accelerate with an acceleration g, such that y is equal to y0, that is the initial position in the y-axis, plus v0y, the initial velocity in the y-axis, times t minus 1/2 of gt squared. Okay. We could also write Torricelli's formula for the y-axis to obtain that vy squared is equal to v0y squared minus 2g times the height y. And also for the x-axis, we have that x is equal to v0x times t, since there is no force in the x direction. So what we have in our problem is a car that is traveling with a speed vx of 30 meters per second, and at some point in its trajectory, it launches a rocket upwards vertically in its own reference frame with a speed of 40 meters per second. In question A, and the exercise also gives us the masses of the cart and the rocket, but they don't really matter, so I'm not going to copy them here. You can see that we can solve the exercise without even mentioning the masses. So in question A, we have to find the maximum height achieved by the rocket. So I'm going to use Torricelli's formula. So we have that vy squared is equal to v0y squared minus 2g h. H is the maximum height, meaning that vy, the velocity at this point, is equal to 0. And as a matter of fact, I think it's better to relabel these velocities here. So v0x is 30 meters per second, while v0y is 40 meters per second, because this is the initial, these are the initial velocities of the rocket. Okay, so at the height of the trajectory, the highest point, the velocity is equal to 0. So we can isolate and obtain that h is v0y squared over 2g. Okay, so h is 40 meters per second squared divided by 2 times 9.8 meters per second squared. So h is equal to 81.6 meters. Then we move on to question B. Question B asks us where the rocket will land relative to the car. Now notice that the rocket does not have any speed in the x direction relative to the car. So v0x prime here means relative to the car, is 0. So the rocket relative to the car will fall exactly where it was launched, and that was exactly over the car. So the rocket will fall on the car. Okay. Then question C. We have to find how far the car moved while the rocket was in the air. Now notice that we can find how much time it takes for the rocket to fall back. That is how much time the rocket spends in the air, And to explain it, I'm going to show here again the figure of the projectile trajectory. So notice that at the highest point of the trajectory, Vy is equal to 0. And we know that Vy is equal to V0y minus gt. Okay. This is just the uniformly accelerated formula for the velocity. At the height of the trajectory, Vy is 0, so at the height, the time t is V0y divided by g. Now notice that the time needed to complete the trajectory by symmetry is 2 times the time needed to reach the maximum height of the trajectory. So the time, I'm going to call it capital T, necessary to reach the top of the time for which the rocket was in the air is 2t, so that's 2v0y over g. 2v0y is 80 meters per second, while g is 9.8 meters per second squared. So capital T is equal to 8.16 seconds. And the distance x that the car traveled is just v0x times the time t. So that's 30 meters per second times 8.16 seconds, and this is 244.8 meters. Okay, in question D, we have to find what is the angle measured by an observer that is at rest with the ground. What is the angle that the rocket makes with the horizontal? So again, this is the rocket's trajectory. Just as it is launched, we want to calculate this angle theta here. Notice that we can draw a right triangle such that the tangent of theta is v0y divided by v0x. So theta is the arc tangent of v0y, that's 40 meters per second, divided by v0x, which is 30. So theta is equal to 245 meters. Actually, I'm sorry. Theta is equal to 53.13 degrees. This is the answer to question D. Then in question E, we have to sketch the height, the trajectory of the projectile according to an object, to an observer that is moving with the car. And as I said, according to the car, the rocket does not have any velocity in the x direction. So the movement is just a straight line up and then a straight line down along the same trajectory. Then for an observer at rest with the ground, the trajectory is something like this. Okay, the maximum height is always 81.6 meters. And the range in the second case is 244.8 meters. And this is the conclusion of our exercise.